We like to think that people are in control, that our world is shaped by big decisions made in capital cities or, corporate boardrooms. But what if the real rulers aren't people at all? What if, underneath all the noise of our daily lives, our world is quietly being shaped by something else entirely? Okay, let's get into it. It's the ultimate question, isn't it? We spend our lives trying to figure out the flow of power, trying to see who's really pulling the levers behind the curtain. And in this explainer, we're going to challenge some of your biggest assumptions about who's in charge. So let's start with the usual suspects. Your first thought might be political leaders, right? Presidents, prime ministers, the people we elect. But just think about it for a second. How often do they seem to be reacting to events rather than actually directing them? The truth is, they're often boxed in by economic forces, public opinion, and global trends that are way beyond their control. So yeah, they hold power, but they are not the ultimate source of it. Okay, all right, so what about the ultra-wealthy? The CEOs and tech titans who seem to have so much sway? And they're incredibly powerful, for sure, but even they have to answer to the whims of the market, the pressures of competition, and the just totally unpredictable nature of new technology. They're just very, very successful players in a much larger game, a game that has its own set of rules. The real answer, the one that's been hiding in plain sight this whole time, is this: invisible equations. Yep, hidden mathematical formulas that have basically become the operating system of our civilization. They're quietly dictating who wins, who loses, what rises, and what falls. Power today isn't random. It's calculated. So to really understand how this works, we have to follow the clues. Think of it like a mystery. And our first clue? It takes us all the way back to the 19th century, and it reveals a pattern in society that behaves almost like a law of physics. Back in 1896, an economist named Vilfredo Pareto noticed something bizarre while he was studying land ownership in Italy. He found that 80% of the land was owned by just 20% of the people. Now, at first, he probably thought it was a fluke, right? But then he checked wealth, and he saw the exact same pattern. He looked at other countries, same thing. It turns out this 80-20 rule applied to almost everything. And this chart just lays it out perfectly. Whether you're looking at wealth or social media influence or business success, you find this deep, profound imbalance. A tiny number of inputs, in this case, the 20%, create the vast majority of the results. The most important thing to get here is that this isn't about fairness or politics. It's just a mathematical tendency. So why does this even happen? Well, it's driven by a feedback loop that scientists call a power law. It's actually really simple. The more you have, the more you can get. If you have more money, you can make bigger investments. If you have more followers, the algorithm shows your stuff to more people. This isn't good or evil. It's a universal pattern that explains why power and influence just naturally concentrate. Okay, so that helps explain inequality. But what about conflict? What about cooperation? Let's move on to our second clue and see how this all builds. Turns out there's math for that too. It's called game theory. Let's really break down what's happening here. This is the famous prisoner's dilemma. And the core insight from the brilliant mind of John Nash is that we don't always choose what's best for everyone. We choose what's safest for ourselves. If you look at the options, betraying your partner always seems like the smartest, safest move, no matter what they do. But here's the kicker. If you both betray each other, you both end up with a worse outcome than if you had just cooperated in the first place. It's a perfect mathematical trap. And believe me, this isn't just some thought experiment. This mathematical logic is the reason why systems get stuck in these patterns that literally nobody wants, but nobody can escape from. It's why arms races escalate when nobody wants war, and why companies get locked into these price wars that hurt everybody. The system settles into an outcome that is mathematically stable, but collectively absolutely terrible. Now, these mathematical laws, they've always existed, kind of humming along in the background. But in the 21st century, we didn't just discover them. Oh no, we built them into the very machinery of our world. And now they're running at the speed of light. I know, this probably looks like total gibberish, but this is the Black-Scholes formula. Back in 1973, it was just a theory on a dusty blackboard. Today, it is the engine of modern finance. It's a single equation that basically tells the entire global system how to price risk and uncertainty. And its influence is, well, it's staggering. We're talking over $1 quadrillion in complex financial instruments called derivatives, all priced using the logic of this one formula. That's one mathematical idea shaping the flow of more money than actually exists in the entire world. And when the assumptions baked into that equation turned out to be wrong, like they did in 2008, this same formula helped accelerate a global financial meltdown. That's the kind of power we're talking about. Today, these equations are absolutely everywhere. They're the algorithms that have become the new laws of motion for our civilization. Think about the news you see on your phone. An algorithm designed to maximize your engagement is curating your feed, deciding what information you see and what you don't. And it doesn't stop there. When you apply for a loan, it's not really a person who makes the final call. It's an algorithm, analyzing thousands of data points to calculate your creditworthiness in a fraction of a second. And what about the stock market? While algorithms are executing massive trades faster than a human can even blink, reacting to market swings in microseconds and moving trillions of dollars every single day. And yes, even in the political arena, they're used to micro-target voters, shape public opinion, and even influence the outcome of elections. These algorithms are invisible. We never voted for them, but they are, make no mistake, increasingly in control of our lives. All of this leads us to our next big idea, network theory. It's the study of how things are connected, and it reveals a critical vulnerability in our modern world. See, our systems are built for efficiency, which means power gets concentrated in a few critical hubs, a few megabanks, a few dominant tech platforms. Now, that's great when everything's working smoothly, but it's also incredibly fragile. The 2008 financial crisis wasn't just a market crash, it was a network failure. One hub, Lehman Brothers, collapsed, and the entire global system nearly shattered with it. This idea of network fragility, that's the final piece of our puzzle. So, we've looked at inequality, we've looked at conflict, and we've looked at the machinery of the modern world. Now it's time to bring all these clues together. It's time to solve the mystery and finally see the underlying code of power. Here it is, the final unifying principle. Whether you're looking at a rainforest, or a city, or the global economy, the pattern is exactly the same. Systems naturally evolve to become more efficient. And efficiency always concentrates power in apex predators, in central airports, and in monopoly algorithms. Power isn't usually taken by force. It just accumulates mathematically as a side effect of making things run better. So here's the crucial takeaway. The world isn't as chaotic as it seems. There's a hidden architecture underneath it all. Power follows rules, wealth follows patterns, and if you can learn to see these equations, these invisible forces, you can start to see the world as it truly is. And that leads us to the final and maybe the most important question of all. These mathematical forces are incredibly powerful, but they are not destiny. They were designed, they were implemented, and they were scaled by people. So if you can understand the equations of power, if you can see the code, who's to say you can't be the one to help rewrite it?